Many people imagine the end of the world as an asteroid strike that destroyed the dinosaurs, or a nuclear war with the entire arsenal of mankind. But what if all this is not even close to what could turn the planet into a hot hell? In order to turn our beautiful blue planet into hell, we need to look inside it. At a depth of about 70 kilometers, a part of the Earth begins which is called the mantle. Deeper, up to 2,890 kilometers, this layer reaches the core of the Earth and contains approximately 80% of the entire volume of our planet. The deeper, the hotter the mantle becomes, from 200 degrees Celsius at the Earth's crust and up to 4,000 degrees at the core. These are quadrillion tons of hot, molten, circulating rock and minerals called magma. Lithospheric plates move due to the movement of heat in magma from the core to the Earth's crust. By their movement, they create mountains and depressions, cause earthquakes. In some places, called magma plumes, hot magma moves to the Earth's surface in relatively small streams or jets, accumulating in the crust if it does not find an easy way to surface. This leads to the formation of magma chambers and calderas, which will form the basis for the emergence of volcanoes and supervolcanoes. So what could happen if millions of tons of hot molten magma did reach the Earth's surface? Let's take a look at two very famous volcanic eruptions. It'll focus on the eruption of the Krakatoa volcano in 1883 and Tambora in 1815. Both of these volcanoes are located in the region of Indonesia, but their eruption has led to consequences across the globe. To understand the strength or danger of any eruption, volcanologists use the VEI scale, the scale of volcanic activity. It's estimated by the volume of eruption products thrown onto the surface, the so-called tephra, and is counted in cubic meters. The eruption of Krakatoa, which claimed the lives of about 36,000 people, caused a 46-meter tsunami, as well as a global cooling of 0.4 degrees Celsius, is estimated at 6 points on the VEI, with the release of tephra up to 10 cubic kilometers. This eruption is equivalent to about 1,000 nuclear bombs, 200 kilotons each, detonated at once. The eruption of Tambora reached 7 on the scale of volcanic activity, which means the volume of ejected tephra is up to 100 cubic kilometers. Taking the lives of 76,000 people, it provoked an even stronger cooling on the Earth's surface by 5 degrees Celsius in some areas. This led to a year without summer, where snow fell even in June in Canada. Hunger in Europe and Asia due to crop failure, acid rain and dry fog in the northwestern United States. And this is only part of the consequences we know. But we're still too far from the complete destruction of humanity. We'd need volcanic super-eruptions reaching 8 points. Super-eruptions are catastrophically gigantic discharges of magma rocks, ash, and aerosols into the atmosphere. Super-eruptions with a volume of thousands of cubic kilometers occur very rarely, and volcanoes and caldera systems that produce them are colloquially called supervolcanoes. The most famous supervolcano is in North America, in the state of Wyoming, the Yellowstone National Park. The Yellowstone caldera, slowly moving northeastward following the lithospheric plate, has already erupted 3 times over the course of 2.1 million years. Each of these super eruptions led to a global climate change. Our entire total nuclear reserve does not even come close to comparing with such a destructive force of the Earth's nature, in terms of the amount of energy in TNT equivalent. About 630,000 years BC, one of these eruptions led to the formation of a caldera 70 kilometers in diameter. The volume of ejected tephra has reached about 2,500 square kilometers, the consequence of which was the abundant ashfall and the formation of Huckleberry Ridge tuff, a layer of volcanic material that's found throughout almost the entire western United States. For comparison, if we take all this volume of hot ash, magma, volcanic rocks, and stuff it into a cube, we get a structure 13 kilometers high, which is almost 1.5 times higher than Everest. If we hypothetically assume that Yellowstone will once again have a super eruption with a volume of ash and solid rocks of 330 cubic kilometers, will this be the end of humanity? This time, we're talking about a cube as high as Mount Kilimanjaro. Using a tephra sediment map, we can see that the ash will spread to almost the entire continental United States and parts of Canada. Everything in the states adjacent to Yellowstone is likely to be completely destroyed in the first hours of the eruption. In the very same Yellowstone National Park, which is about 64 kilometers in diameter, lava, magma, and other products of the eruption will reach a meter in height. A super eruption of this magnitude will cause an almost complete collapse of the North American agro-industry. A cloud of ash will block sunlight from reaching farmlands in the central and eastern United States. Acid rain and tephra will destroy crops, pollute water sources, and kill livestock. In addition to the ashfall, the new super eruption will produce a large number of volcanic bombs, which are the magma itself ejected from the volcano at great speed. These bombs will destroy roads, houses, and communications in the area up to 150 kilometers from Yellowstone. The number of deaths, the total consequences for the whole world, are difficult to calculate. A catastrophe of this magnitude will be possible to compare with the fall of an asteroid several kilometers wide. It's also likely that for a period of up to several years, North America will feel the full impact of the volcanic winter, and the climate of the entire world will be destabilized. Scientists believe that sudden changes in temperature will lead to anomalous natural phenomena. Hurricanes, tornadoes, and thermal domes will appear. This means damage to farming, not only in the United States, but also around the globe. Crop failures, hunger, droughts, and cold snaps will become the norm for several years. It's important to say that despite the rising and falling seismic activity of Yellowstone, scientists have no fears. This supervolcano will almost likely never be capable of super eruptions, or at least for the next thousands of years. In fact, the super eruption has already almost destroyed humanity, approximately 74,000 years BC. The super eruption of 2,880 cubic kilometers, 8 times larger than in the hypothetical model of the Yellowstone eruption, according to scientists Michael Rampino and Stephen Self, could lead humanity to extinction. We're already talking about the super eruption of the Toba volcano on the island of Sumatra in Indonesia. In a 1992 article, they suggest that this super eruption not only led to a volcanic winter, but also accelerated the glaciation process. This is also associated with a bottleneck in human genetics. Some studies find evidence that in the period from about 100 to 50,000 years BC, human civilization shrank to 10,000 individuals at best. This is evidenced by the low genetic diversity of our ancestors, according to the same Michael Rampino and Stephen Self. Until some time, it was believed that the super eruption of Toba led to a volcanic winter of at least 6 years in Africa and Europe, but recent research actually suggests otherwise. In 2018, the results of a study of the tuff and traces of this super eruption were published, and surprisingly, there is evidence that human activity did not stop, but on the contrary, increased. On the southeast coast of Africa, tools were found in the layers of the earth both before and after the eruption. In addition to small sharpened stones, there were also more complex arrowheads and spearheads. Excavations around Lake Malawi, also in Africa, do not provide any evidence of a catastrophic volcanic winter from a super eruption. Most likely, the effect of ash and aerosols was overestimated and could not lead to a 6-year winter in Africa and proximity to the mankind's extinction. But what if the super eruptions are just part of an even more catastrophic event, which has likely led to the extinction of the dinosaurs along with the asteroid, which has also contributed to this? Only now will we come to an event that's really capable of creating a global hell: volcanic floods. A volcanic flood is an event that does not fit into the scale of volcanic activity because the total emissions of ash, magma, and rocks already vary in millions of cubic kilometers. Returning to our comparison with a cube, its height on average reaches space, or 125 kilometers. All this volume of magma and ash pours out over millions of square kilometers, covering them with a giant layer hundreds of meters high. The consequences of this form huge plains, the traps, with a characteristic relief that resembles a staircase. Even if scientists now cannot name the exact reason for the formation of the traps, which cover huge areas in Siberia and India, there is no doubt that this is a large-scale and catastrophic process. Nor is it surprising that the age of the trap's formation roughly coincides with the dates of the largest mass extinctions. One of these led to the extinction of 95% of species of living beings. Unlike super eruptions and asteroid impacts, the impact of a volcanic flood on Earth can last for hundreds of thousands of years. They occur when a plume or a long torch of magma reaches the uppermost layers of the Earth's crust. By comparison, the caldera of the Yellowstone supervolcano is located at a depth of 8,000 meters. Volcanic floods begin with a series of powerful earthquakes and a rise of the surface by several hundred meters. Cracks and ruptures in the uplifted Earth will be accompanied by a series of super eruptions, ejecting tephra and lava in pillars averaging 50 kilometers in height. Magma will slowly melt through the Earth's crust and begin to spread over an area the size of entire countries. In the case of the Siberian traps, which formed about 640,000 years from the beginning of the volcanic flood, we're talking about an area as big as the continental Europe, covered with tephra and magma, hundreds of meters high. This, for example, most likely led to the Permian-Triassic extinction of 250 million years BC. The formation of the Deccan traps led to the Cretaceous-Paleogene extinction 66 million years ago and the death of the dinosaurs. The effect of volcanic floods on the climate is thousands of times greater than that of super eruptions or nuclear war. After most of the magma rock from the plume reaches the surface and spreads, the remaining magma will seek another path, spreading horizontally, reaching coal deposits and other fossils. This alone will lead to a huge emission of carbon dioxide into the atmosphere, which will heat the Earth by an average of 5 degrees. A seemingly small figure means the transformation of most of the Earth's surface into a desert for hundreds of thousands of years. The oceans will turn into a toxic, hot, acidic liquid due to the abundance of carbon dioxide and the activation of methane deposits at the bottom. But, as we can conclude from the fact of our existence, the planet is able to endure such disasters, and more than once. Scientists are sure that for the next hundreds and thousands of years, mankind is unlikely to meet with such cataclysms. What about you? Would you like to observe similar phenomena? We will inform you if the plans of the volcanoes change and such an opportunity arises in the world. So stay tuned, and thanks for watching.